This video is about finding the volume of solid of revolution using the disk method. What is solid of revolution? Solid of revolution is a solid generated or formed when a region in the plane is revolved about a line, and the line is called the axis of revolution. Disk. If you revolve a rectangle of height r, just like this is a rectangle of height r and its width is w, about this line, it will generate a disk like this one, and the volume of this disk would be the pi times r squared w. Let's say pi r squared is like the area of the circle, and the w is like a width or height of the disk. Now, if you revolve a right triangle, the base h on y-axis, and with the r is the height of the triangle, and about y-axis, it will generate a cone, circular cone, like this. So let's say finding the volume of solid of revolution. Let's say what is disk method? Well, this is a technique to express the volume of a solid as the limit of sum of the volumes approximating disks is called the disk method. Suppose that a solid is formed by revolving a region under the curve. So this is your curve, this one, and this is the boundaries, x equal to a and x equal to b, and we're going to revolve this region about the x-axis. So to find the volume of the solid, we can subdivide the region into vertical rectangles with a base on the axis of revolution. So because this is the axis of revolution and the base of the rectangle is here. And the width of the rectangle is delta x, and the height is r of xi. I mean the height at point xi. Now, by the definition of this disk, solid generated by the ith rectangle is the disk. The volume of the ith disk is area of the circular cross section times the width. So as you notice, the radius of the disk is r, and the width of the disk is delta x. So it's a pi r squared times delta x. The total area of the solid. So if you calculate the area of all the rectangles, so you add all this, and you can write like this: summation I from 1 to n pi times r xi squared times delta xi. And then you can take this is the total volume. This is the volume of the one disk. So the volume, you take the limit, and approaches infinity, I from 1 to n pi times r of xi squared delta x. So this is by the definition of definite integral. So that will be equals to integral from a to b I times r x squared dx. So you have to remember r is the height of the rectangle in the given region. So this is the formula we can use to find the volume when you use the disk method. Now, when to use disk method? Well, if you use the disk method when you are trying to find the volume of solid of revolution generated by revolving a plane about the x-axis and the base of the plane is on the x-axis, or about y-axis and the base of the plane is on the y-axis, or about any line and the base of the plane is on the line. Then you use the disk method. And if the base of the plane is away from the line, then you cannot use this method. You have to use a method called washer method, which we'll discuss in another video. Let's see how to use this method. If you are required to find the volume of the solid found by revolving the plane bounded by the graphs y is equal to f of x and x equal to a and x equal to b. And about the x-axis, you should do the following. Draw the rectangle perpendicular to the x-axis. So just like this one. So perpendicular to the x-axis. And then you have to use the formula v is equal to integral from a to b pi times r of x squared dx. And then replace the r of x is the function f of x, whatever is f of x equals to. And then replace a and b, whatever a and b are given in the given problem. And then evaluate the definite integral, and you will get the volume of the solid of revolution. If you are required to find the volume of solid of revolution by revolving the plane bounded by the graphs y is equal to f of x, y is equal to c, and y is equal to d about the y-axis, then you have to draw the rectangle perpendicular to the y-axis in the region. So and then you have to use this formula v is equal to c to d pi of r of y squared dy. And then you have to write y is equal to f of x as x equal to f of y. And then replace the r of y by f of y. So in other words, you're given y is equal to f of x, so you have to solve for x. So in x is a function of y. And then you replace this r of y by f of y. And replace c and d, whatever the limits you are given the numbers. And then evaluate the above integral. Let's take an example. So we're going to write and evaluate a definite integral that represents the volume of the solid formed by revolving the region about the x-axis. So here we have a y is equal to minus x plus 2, and so we draw this line graph y is equal to minus x over 2, just like shown in this one. So here we're going to revolve about the x-axis. So this is the one boundary, and this is this one. So we have to revolve this for x equal to 0 and x equal to 2 about the x-axis. So we're going to draw a rectangle perpendicular to the x-axis. And we use this formula y is equal to a to b pi times r of x squared dx. And r of x is equal to y or f of x. You put that one. And here x is 0 and x is 2. So replace a with 0 and b with 2. Now to find the definite integral, first we expand minus x plus 2 squared. So it becomes the square of negative x squared, and then you multiply and double it to give you negative 4x and 2 squared before. So replace this one, so integral 1 becomes pi times 0 to 2 x squared minus 4x plus 4, and then you have to use this power rule of integration. So when you apply the power rule, you do not have to write the integral symbol. So you write pi, and this becomes x 2 plus 1, 3 divided by 3, 4x to the power 1 plus 1, 2 over 2. And this is a constant, and the integral of constant is constant times the x. Now this indicates that you may have to take the limits 0 to 2. So first you're going to substitute 2. So it becomes pi is equal to 2 to the third over 3 minus 4, 2 square over 2, and plus 4 times 2. And then you have to say subtract, and then you substitute the lower limit. 0 cube over 3 minus 4 times 0 square over 2 plus 4 times 0. So this all goes to 0, and you're left with this pi times 8 over 3 minus 8 and plus 8. So it becomes pi times 8 over 3, which is 8 pi over 3. So that's the volume of the solid of repletion. So here is an example 2. So we're going to write and evaluate the definite integral that represents the volume of this solid formed by revolving this region bounded by this about y-axis. So we sketch this one, y is equal to square root 25 minus x squared. So this is the graph, and this is the region. We're going to revolve this about y-axis. So we're going to draw the rectangle perpendicular to y-axis. Since the rectangle is perpendicular, so we're going to use formula v is equal to c to d pi times r squared dy. So from the picture you can see c is 0 here, and c here is d is 5. And the given is y is equal to this square root of 25 minus x squared. We have to solve for x. So we start with this one. So y is equal to square root of 25 minus x squared. We square both sides because y square square root of 25 minus x squared, square root cancel out, gives you 25 minus x squared. And move the minus x squared to the left side and the x squared and y squared to the right, minus y squared. Now we take the square root, gives you x equal to square root of 25 minus y squared. So now we're going to substitute, but the y is this one, square root of 25 minus y squared. And the c would be 0 and d equals to what? 5. So we have now v is equal to 0 to 5 pi times the square root of 25 minus y squared, and because this is squared. Now we square this, radical becomes 25 minus y squared. We factor pi and then we integrate 25. 25 is a constant, so it will be 25 times y 25. Here we can apply this power rule. So you add 1 to 2 becomes y cubed and then divide by 3. And then we substitute the limit from 0 to 5. So first we substitute y is equal to 5. So it becomes pi times 25 times 5 minus 5 cubed over 3 minus 25 and 5 times 0 minus 0 cubed over 3. So this whole goes to 0 and you get here pi times 125 and 5 is 125 over 3. Now if you multiply 3 times 125 it becomes 375, and then you subtract 125 it gives you 250. So the answer is 250 pi over 3. Okay, so here is another example. So we're going to find the volume of the solid generated by the graphs of the equations about this line x equal to 5. And the region is made of these lines. Y is equal to x, y equal to 0, y equals to 4, x equal to 5. So you graph all this. So this is y is equal to x, this line, slant line. And that is this line is y is equal to 4. And this is y is equal to 0. And that line is what? X equal to 5. So this region, we're going to revolve about this vertical line x equal to 5. So we draw a rectangle perpendicular to this line. So since we're revolving about the vertical line, we're going to use this formula. V is equal to from c to d pi times ry squared dy. Okay, so we need a c, so looks like the lower limit is here 0, c0, and here d is equal to 4. And ry, we're going to use this line the length of this rectangle. So this is R. So R would be from here to here is 5, and from here to here is x. So R of y would be 5 minus the x. But x equals to y, so then this becomes R of y. We have x equals y from this equation. So this becomes R of y equals 5 minus y. So now we substitute c is equal to 0, t is equal to 4, and r is equal to 5 minus y. So we're substituting R of y 5, y minus 5, c equal to 0, and d is equal to 4 in this formula. So they become 0 to 4, 5 times y minus 5 squared dy. Now we will square this, y minus 5 squared. So y squared, 5 squared is 25, that's the inner term, and that you multiply and double it, negative 10y. Okay, so now we integrate y squared, use power rule, because y cubed over 3, and then power rule, y squared over 2, and 25 is a constant, so it'll be 25 times y, because we are integrating with respect to y. So now we first substitute y is equal to 4, so it becomes pi times 4 cubed over 3 minus 10 times 4 squared over 2 plus 25 times 4. Then put subtraction, always subtract, and then substitute 0. So it becomes 0 cubed over 3 minus 10 times 0 squared over 2 plus 25 times 5 times 0. I think this is an extra 0. So 25 times 0. This whole thing goes to 0, and it becomes 4 cubed is 64 over 3. 4 squared is 16, divided by 2, 8. 8 times 10 is 80. And 25 times 4 is 100. So 100 minus 80 would be 20, and then 20 times 3 is 60, subtract add 16, 64 would be 124. So the answer is 124 pi over 3. So here's an example 4. So we're going to find the volume of the solid generated by the revolving the region bounded by the graphs of the equations about x-axis. So this is the equation, this is, and these are equations. So since we're revolving about x-axis, draw the perpendicular, draw the rectangle perpendicular to the x-axis. So this is boundary here, x is 0, and here x is 2, and here this is r. R is the f of x, which is e to the minus 3x. So we're going to use this formula. V is equal to a to b pi r x squared dx. And then we substitute r of y is equal to minus e to the 3x. A is equal to 0, b is equal to 2. So we substitute r of x equal to y is equal to e to the minus 3x. And a equal to 0, b equal to, as we said earlier. So the integral becomes 0 to 2 pi times e to the minus 3x squared. So you square this one, here basically you multiply the power. So they become pi times e to the minus 6. And then the antiderivative absolute exponential function is the exponential function divided by the coefficient of dx. So it becomes pi times e to the minus 6x over negative 6x. Substitute 0 to 2, so first we plug 2, it becomes negative pi over 6 e to the minus 6 times 2, and then minus, substitute x equals 0, becomes e to the minus 6 times 0. This becomes negative pi over 6, this is going to the minus 12, and this going to 0. Now d to 0 is 1. So we can distribute, and it gives you negative distribute. So now it becomes pi over 6, 1 minus e to the minus 12.